Well, I'm not sure how to read this name. Varab, Varabaram Ramanathan estimated that these trace gases could add 40% to the warming effect of carbon dioxide. So Ramanathan has contributed to many areas of the atmospheric sciences. His first major findings were in the mid-1970s and were related to the greenhouse effect of CFCs and other trace gases. Until that time, carbon dioxide was thought to be the sole greenhouse gas responsible for global warming. He also contributed to the early development of global circulation models and the detecting and attribution of climate change. So he then switched to the radiative effects of clouds on the climate. This was done using the Earth Radiation Budget experiment, which showed that clouds have a large cooling effect on the planet. So also be able to measure the greenhouse effect without the use of climate models. So this guy Claudia Loris. So in 1985, a French Soviet team by the Claude Loris produced a 150,000-year ice core record from Vostok, Antarctica that showed large fluctuations in past carbon dioxide levels from 180 to 280 parts per million that correlated closely with temperature changes of the order of 8 degrees Celsius. From 1990 through 2007, for assessments by IPCC have refined the estimates of global warming by 2100 to 2.5 plus or minus 1 degree Celsius relative to 1980 to 1990, with a carbon dioxide concentration that will reach about 700 parts per million. It is clear that global climate is not stationary. However, non-stationary can take several forms. There may be a gradual or abrupt shift in mean conditions, or there may be change in the degree of variability such that the distribution of extremes is altered. This can occur with or without a change in the mean value. An increased frequency of hot, cold, or wet and dry days can lead to warmer, colder, or wetter, drier climate. A further possibility is that there are quasi-periodic oscillations without a change in the mean state over a long period. The frequency of circulation patterns may change over time, and this could reflect natural variability in the atmosphere, or it could be a response to global warming. Using pressure data from 20 stations over Europe, 30 to 70 degrees north to 30 degrees west to 40 degrees east, a zonal pattern and a blocking cyclonic pattern have been identified by Sloanovics et al. During 1822 to 1870. The circulation was more meridional with blocking cyclones patterns, whereas for 1947 to 1995 it was more zonal. The radiative forcing due to atmospheric GHGs since about 1800 is 2.3 watts per square meters. This is made up of contributions from carbon dioxide, methane, nitrous oxide, halocarbons, and tropospheric ozone. Aerosol sulfate, organic carbon, nitrate, and dust give rise to cooling through direct radiative effects and indirect effects on cloud albedo as a result of cloud droplet concentration with a total radiative forcing of negative 1.2 watts per square meters. However, the effects of black carbon deposited on snow lead to a small positive contribution. Changes in land use give rise to a cooling effect as a result of increase in albedo. The total net radiation forcing for all sources is estimated currently to be 1.6 watts per square meters. Natural climate variability is attributable to solar variation, volcanic eruptions, and randomness in the atmosphere, ocean system, solar variability over the 11 years. Some spot cycle is at most 1 watts per square meters, which gives only 0.25 watts per square meters when averaged over the Earth. Volcanic eruptions releasing sulfate aerosols lower hemispheric or global temperatures, depending where the eruption occurs, by up to 1 degree Celsius in summer for 1 to 2 years after the event, but there were few major eruptions in the 20th century. Temperatures in the 20th century rose to an initial peak in the 1930s and 1940s, then declined or leveled off, and have risen continuously since the mid-1980s. The warmest year on record occurred in the late 1990s and 2000s. The early to mid-century warming, which was most marked in the northern North Atlantic, is potentially attributable to natural variability. The decline in northern hemisphere temperatures in the 1960s to 1970s is attributed to higher sulfate aerosols levels in the atmosphere due to industrial activity. Over the period 1950s to 1980s, there was a global dimming with a reduction in direct solar radiation by 46%, attributable to this effect. Surface solar radiation decreased by 3 to 7 watts per square meters per decade in major land areas, a global brightening. 2 to 8 watts per square meters per decade succeeded this during the 1980s to 2000, except in India, and the trend has continued in the United States and Europe as a result of controls on air pollution. In India, the negative trend continues, and in China, Mongolia, the trend turned negative after 2000. The brightening has contributed to the post-1980s global warming. According to Mr. White, since 1980, global temperatures have been rising by 0.05 degrees Celsius, with the three warmest hemisphere the warmest years on record since 1850 being 2010, 2005, and 1998. The northern hemisphere land surface has warmed by about 0.01 degrees Celsius for the years since 2001. The land surface in the northern hemisphere, southern hemisphere warmed by 1.12 over Celsius over the period 1901 to 2010. According to Jones et al., the Arctic temperatures have increased at almost twice the global average rate in the past 100 years as a result of polar amplification involving the effects of ice albedo. Positive feedback. This operates through a decrease in snow and ice cover, exposing bare ground on ocean with much lower albedos. The consequent increase in absorbed solar radiation raises the temperature, leading to further decrease in snow and ice cover. This effect, together with the advection of air water and warmer air from mid-latitudes, gives rise to an increased Arctic warming, and discussed by Sir Renzies and Berry. Significant warming has also been observed in the Arctic Peninsula, where air temperatures have risen about 3 degrees Celsius since the 1950s. This led to the disintegration of several ice shelves in the northern part of the peninsula over the last 2 decades. So, the key message here, I want to point it out that the radiative forcing due to this has been the effects. However, the effects of black carbon deposited on the snow led to a small positive contribution. So changes in land use gives rise to a cooling effect as a result of increases albedo. So the effects of black carbon deposited on snow led to a snow positive contribution that the albedo increases and it gives a cooling effect. Okay, the radiative forcing due to anthropogenic greenhouse gases since about 1800 is 2.3 watts per square meters. This is made up of contributions from carbon dioxide, methane, nitrous oxide, halocarbons, and tropospheric ozone, aerosol, sulfate, organic carbon, nitrate, and dust give rise to cooling through direct radiative effects and indirect effects on cloud albedo as a result of cloud droplet condensation with a total radiative forcing of 1 to negative 1.2 watts per square meters. However, the effects of black carbon deposits on snow lead to a small positive contribution. Changes in land use give rise to a cooling effect as a result of increased albedo. Between 1900 and 2008, the global ocean warmed by about 0.06 degrees Celsius with the western boundary currents, the Gulf Stream, Kuroshino, the Brazil Ahagas, and the eastern Australia currents warmed by 1 to 1.4 degrees Celsius. This attributed to a poleward shift in the mid-latitudes extensions of these currents. The role of winds is unclear as the southern hemisphere, the westerlies strengthened, but not the northern hemisphere. Nevertheless, these warmer currents will affect the ocean atmosphere heat transfers and the development of cyclones. During the last 3 to 4 decades, the frequency of El Nino events has increased while La Nina events decreased. Wow. So El Nino increased, La Nina decreased. And then, this has been attributed by some scientists to global warming, but the case is not yet established. In the last 3 decades, there has been an expansion of the tropics in the northern hemisphere. Various metrics show an average expansion between 1979 and 2009 of 0.33 per decade. Allen et al. Attribute this shift to the heating effects of black carbon, aerosol, and tropospheric ozone, especially in the warm season. The relative frequency of cold spells has decreased and the frequency of hot days has increased over most land areas in the late 20th century. In Europe, the frequency of hot days has tripled since 1880. In the United States, there has been an increase of about 12 days in extreme apparent temperatures. In the 60 years since 1949. In the Colorado alpine ozone, the area classified as tundra according to the Köppen classification shrank by 73% between 1901 and 1930 and in 1987 to 2006 as a result of summer warming. According to Des and Astert, drought areas have increased, especially in the tropics and subtropics. There has been widespread drying over Africa, East and South Asia, East Australia, South Europe, Alaska, and northern Canada from 1950 to 2008. Most of this drying is due to recent warming.